Hi, I'm Keon, and in this video I'm going to show you two proofs that show that the sum of natural numbers from 1 to infinity is not equal to negative 1 over 12. I'm sure that many of you guys have seen different proofs from Numberphile that by rearranging terms they showed that this sum approaches negative 1 over 12. But I feel like, as they say, this is true that this result is just used for the physics world and the physics applications since we can't have infinity. But since we're talking about series, different tests for convergence, divergence, we don't have to think about the physics world. We are in the mathematical world and we should use applications and different techniques to show that this kind of question makes sense in the mathematical world. If we just write 1 plus 2 plus 3 plus 4, it doesn't make sense to get negative 1 over 12. And but and the proof that they showed by rearranging the terms, this proof can be used like on many different ways that you can kind of rearrange it many different ways and get a different result. So negative 1 over 12 can't be an answer, and by definition of series, when we have different answers for a single question, we see that there's kind of no answer. It diverges. There's no one answer for it. So we can say that this diverges. But I'm going to show you two proofs that mathematically show that this series diverge. So first of all, I'm going to use the partial sum definition. I'm sure that you know that when evaluating infinite series, the limit of the partial sum would be the answer to the series. Because technically, partial sum, we're taking the first term, the sum of the two terms, three terms, and we're taking this and we are taking the limit as it goes to infinity. So for example, I'm going to show you as an example, if we have the series from n is equal to 1 to infinity, for example, of 1 over 2 to the n, we know that by the geometric series, it would be equal to 1 over 2 over 1 minus 1 over 2, which would be 1. We know that. But if you write the partial sum would be 1 half plus 1 half plus 1 fourth, which would be 3 fourth. So I'm going to just use a comma here because I want to show you that. Um, and then the third term of the partial sum would be 3 fourth plus 1 over 8. So it would be 7 over 8. And so on. And we can see that here that we can actually write a formula for the partial sum. And the formula for the partial sum would be, if I write it at S sub n, the partial sum would be here. In this case, you can write it as 2 to the power of n, 2 to the power of n, and then minus 1 over just 2 to the power of n. And if we evaluate it, so if we put n equals 1, we get 1 over 2. If we put 2, we get 3 over 4, and 3, we get 7 over 8. And if you take the limits of this, so the limit as n goes to infinity of s sub n, we're just taking the highest powers. In this case, is 2 over n over 2 over n, and the limit would be 1. And so we see that the limit of a partial sum is just the answer to the infinite series, which is 1. So this method works. And then I'm going to show you this method for the sum of natural numbers. So let me take here. So let's say we want to write the sum of natural numbers. I'm going to write it as s sub n2, so we don't confuse it with this one. So this would be 1, and then sum of 1 and 2, which would be 3, and then 3 and 1 plus 2 and 3, which is 6. Then it would be 10, and it would go on forever. And you can see that this is actually the triangular numbers. So we can write this as n squared plus n over 2. So if we evaluate at 1, we get 1. At 2, we get 3. At 3, we get 6. And at 4, we get 10. And if you take the limit, let me change the color. If you take the limit as n goes to infinity of s sub n2, we see that the numerator goes to infinity because it has n squared and an n, and the denominator is just 2. So we know that the answer is definitely infinity. So when the partial sum diverges to infinity, then the original sum, by definition, should also be equal to infinity. Those should diverge. We can't say it equals infinity, but more like it goes to infinity. So sum of n equals 1 to infinity of n would be equal to, would go to infinity. And so it would diverge to infinity. So you can say that this is a divergent sum and it goes to infinity. The second method actually requires um, uh, the knowledge of Riemann zeta function, which I'm going to show you in the next video. So I'm going to upload it right after this video. I hope you have a good day and goodbye.